how to get developers to love RDF or something. Is that what that's still the topic,
Yeah.
Michael?
I'll be totally honest with you. I didn't know I was presenting, but that's fine. I can do that. I can definitely do that.
Oops. Wow, I don't know. We got our wires crossed there somehow, but
But James did say something about organizing the chaos. James, he wasn't obviously.
Yeah.
Somebody
has to create the chaos.
Yeah, I will say that the Microsoft Teams is very flickery, so I'm not entirely sure how that's going to play. But all right, let me see if I can share my my little. Like I just clicked it and nothing's happening. It's just amazing. Yeah, it's very unhappy right now.
Maybe leaving Teams and coming back in is, that's the old Microsoft. If that doesn't work, reboot. But
God.
Rebooting is a sign of weakness, an old sysadmin told me.
Yeah, but trust me, you don't want my machine to reboot.
It kills your 5 nines, doesn't it?
It will take you forever. Yeah. Hello. Yeah, it's not. I can't get to the share screen here yet.
I must say, listening to everybody do their introductions, it feels like I've met my tribe. People come in and say, "I'm an ontologist and I'm working in semantic web."
Yeah.
Hey,
yeah.
Nice to meet people.
Well, that's too bad. Wow. Well, I can certainly talk my way through this without any slides. I know you guys won't be happy, but here's the big picture, right? Developers, I've been told many times, right to my face, we will never, ever program in Sparkle. I mean, they've just said there's just no way in hell they're going to do that. And the reason is they have just too much invested in whatever methodologies they're used to. The classic pattern these days is a REST API. Unfortunately, REST has gotten a bad rap for a very good reason, because I would say probably about 80% of the APIs I've seen are just really poorly designed. So people assume that that with poorly designed APIs, there must be something wrong with the product. So they go on to the next thing, and GraphQL seems to be the new API du jour, and ResumeWare as well. So, but the point is that we need a nice way of simplifying it, and the REST API won't work for front-end developers by itself, because if the thing that they're building, the application that they're building, which is almost always, not always, but typically within an enterprise, they're going to be building a very closed world application. They're going to show a list of employees, or they're going to show a list of products, or they're going to shopping carts, whatever. I mean, so a lot of what front-end developers do is deal with lists. And they don't want to go hunting around for those lists. They want those lists to be self-described and discoverable. So we can do a lot with modeling by putting hints in our model, as well as agreeing on a common set of container types, which I'll call, and having stolen this from Michael and probably David as well. I really liked the word bucket. I know that was introduced many years ago, and perhaps it fell out of favor with you, but I've been using the word bucket for 20 years. And the developers I work with also have used the word bucket. So it's something they're very familiar with. So if we think of a bucket simply as a modeled handle, so basically it has a name, like laptops, and laptops might be a type category. So, laptops becomes the handle by which I'm going to find lists of things that are related to that. And that's the key thing, is that they want these well-defined, discoverable handles, triggers, whatever you want to call them, so that they can then query the data, the repository, to get stuff back out for their front end application. Now, the way they want this to work is they don't want to know anything about RDF. They don't want to know anything about SPARQLE. And frankly, they don't even really, if you're smart about this, they don't even want to know what the names of the attributes are. Those should be something that is discovered on a per category or per tag basis. And so that's the thing of hints. In other words, the last thing I want is to see a front-end developer hardwire something in their front-end code. Like, imagine they hardwired the word price or the color or description or whatever. That's absolutely makes for fragile applications. So what we want instead is to say, here are the ways you discover the kinds of things you can query on. Now, that's part of our model. It's our job to make it easy for them. And here are ways you can then pass those keys back, those handles, and get a payload that you're going to be very familiar with. And the payload they're looking for is JSON, and it's easily done through REST. There are other ways to do it, of course. And I go on to show in the slides that Oracle has an interesting way of doing it, because Oracle's RDF, which comes free with every Oracle database, basically is stored in the database as tables, and is called internally through an extension to SQL called semmatch. And so basically, it's trivial to create PL SQL statements, which can then invoke SPARQLE directly, the same exact SPARQLE you would use on a SPARQLE endpoint. And given that a lot of our Oracle's customers are bound to having lots of relational data, for example, they might have relational data for custom pricing, or relational data for inventory, or any number of things, right? Those are the kinds of data that you're not going to put, and you shouldn't put. In fact, I'd argue it's an anti-pattern in your semantic database, right? So what's kind of cool? Yeah, go ahead.
Michael, I was going to say, can we pause for a bit and respond to some of the,
absolutely.
Let's see the dialogue on it.
Please interrupt me. Yeah.
Yep. Because no, I think you've already turned over a lot of very good stones that I think people will have opinions about. One or two, and there's a little hand waving feature, hand raising up there in the upper menu. So if anybody wants to jump in, raise your hand. But here's a couple of things I would love to hear people respond to. One is, have you encountered any developers or have you come up with any strategies that get developers over this hump? I mean, I think you got a valid concern there. I'm not sure that we will never get developers to do this. Second question is, and I totally agree with you, but I'm not 100% sure what the strategies are about not having developers hardwire things they find in queries into their UI, because they've been doing that forever. And in fact, I think your Oracle suggestion, if you combine a SPARQLE thing with a SQL, they're going to get stuff back and say, oh, there's price. I'm just going to, so anyway, there's two things to react to, and there's probably people parse it a little bit more, a couple more things to react to. Let me just turn it over to the group. Raise your hand. Mark, what do you think?
You mentioned the term bucket earlier, Michael, near the beginning of your talk. It sounds familiar to me in a way that I come from a semantic digital twin world, where you can create a digital twin of anything you like, and then you give it RDF type fish. Okay, it's a digital twin of a fish. That's the kind of the philosophy that we have. But we come across use cases, something like a situational awareness use case, where maybe there's been an accident and the car manufacturer knows something about it, the owner knows something, the breakdown people know something, the dealership knows something, and you've got a need to kind of collect that data together into something, but nobody owns the something. Is that the kind of thing that you were talking about with a bucket, where you can just throw a bunch of triples at it and say that's a thing? Because that's pretty much the approach we take.
Yeah, I'd rather not use the word triple, simply because for me, I like to approach projects from a rather than an API first approach. I like to do it from a payload first approach. So bottom line is, if a front-end developer cannot describe the payload that they want returned from the query, then you shouldn't proceed in the project. I mean, you know, that's something that's critical. You really want them to document. You want them to collect their business requirements, and then you want them to document it and say, all right, for me to do my job, for this screen, for this function or whatever, I need this payload coming back from your stuff, right? And it may be that you just so already we have a presentation layer, which is perfect because that's the view, right? Then we want this control layer that determines, you know, should I go out to a SPARQLE? Should I go out to this, you know, relational table or NoSQL or whatever, or should I munge it all together, right? And that's really the job of the controller. And we want the front end guy to not care where it comes from. And so I don't want to use the word triple because maybe the data is not going to come from the SPARQLE piece of it. But that to your point, yeah, I want my business objects basically categorized or tagged or grouped. And those are three different entities, right? If anybody's catching on to that. So my presentation was using just as an example of how one might go about building buckets. And my caution to people was, you know, try to not consider classes as buckets, simply because it's not that you shouldn't and can't. It's just that it's overused, right? And people tend to build these giant class trees, and then developers build applications against them, and then all of a sudden people want to change those trees, and it becomes somewhat nightmarish and very fragile. So I'm trying to prevent the developers from creating fragile applications.
Yep. Good aspiration.
I don't want them doing mashups in the view. So I don't want them calling the pricing database separately, right? I want them to basically call a controller and let the controller should do this. Now, in the way that Oracle does it is our controller plane is PL SQL, and PL SQL can use on a converged database. We can call out to SPARQLE, or we can call out to property graph, or we can call out to relational or NoSQL or whatever, right? And so, you know, for people who know Oracle, that's a great control plane. And then the repositories, of course, can be appropriate. So obviously for semantic data, we want particularly highly interrelated stuff. We want that to be in a graph. For things that are relational or very temporal and time changing, probably best to have that in some sort of relational table or whatever the application is, whether it's supply chain management or ERP or whatever. So, you know, it's just an idea of trying to prevent fragility. And if we as semantic modelers don't make this effort and somebody forces developers to work with us, what's going to happen is they're going to hardwire their SPARQLE into some sort of Java API or whatever. And then they're going to do mashups in their front end, and they're just going to make a mess of things. And why? Because what's cool about graphs is how flexible they are, and we want them to remain flexible. And I love your idea, David and Michael too, about don't start off with the fewest number of classes, and then later on, if you've got some sort of entity like a category or whatever, and it needs to be a class because you created some real good reason for it. It's easy to convert something that's not a class into a class, but it's harder to do the other way around.
Yep. Hey, Aura's got his hand up, and so do I, but I'll let Aura go first.
Okay.
Yeah, a couple of things. So the idea of a triple came up, and I think that sort of makes me think about the kind of the right level of abstraction, how you deal with this data in your code, and triples tend to be too low level anyway. So, you know, I'm sort of against exposing triples to the logic part of an application. I mean, triples are like assembly language, right? We don't program in assembly language. Triples are super important for two groups of people. People who build RDF databases and people who care about the formal semantics of RDF. Other people should not have to deal with triples. So, so that's one. And the question of classes. So I think that classes in RDF are sometimes kind of misunderstood. I don't consider classes to be bad, but some people sometimes use classes when in fact they should use some kind of roles or something like that. So for example, I just had a customer who I was advising, and they are building a knowledge graph about that contains people and some other things about their organization. And people, this is an educational institution, so they can be students, or they can be alums, or they can in fact be faculty members. And they had first wanted to do this with classes, and I said, well, okay, but what if a student becomes an alum and then maybe becomes a faculty member?
Right.
So how are you going to do that? And so that sort of led them to think about more sort of that there's just a class of people, and then the role is modeled separately. Now, when can you use a hierarchy, a class hierarchy? So I think that an RDF class hierarchy is no different than a class hierarchy in some object-oriented system. And I think that so in the past, there has been some evidence that average developers don't really understand object-oriented programming very well.
Yep.
Well, you know, this may be
even though that's driving their adoption of Neo4j, for example, because although you're absolutely right, they don't really understand classes. These are familiar patterns to them, and so they go, "Oh, I see how this works. I can work with this." Whereas they look at SPARQLE and RDF and go, I don't see how that works, and I can't work with that. So you're absolutely right. They see the world as object, and yet they don't really understand the nuance of objects.
Yeah, I very much would like to see some kind of an abstraction that would easily let people write code that consumes graph data. I've been sort of toying with this idea of what I call object graph mapping, you know, sort of but the problem becomes, how do you sort of circumscribe a suitable chunk of data from the graph that would constitute, quote unquote, an object?
Yeah.
Well, yeah, and yes, this gets.
I have my hand up. I've been patiently having my hand up here.
Go for it.
It's good.
Yeah.
It's good exercise.
Yeah. So I've got a couple of responses that are interesting. It's too bad Tristan's not on the call, but so the first question was, you know, can or will developers adopt this? And internally, we've had very good success because we beat them over the head and make them do it. That's not always going to work, but to your point, Michael, with our clients, yeah, they have their little patterns. They want to do it however they want to do it, and we're mostly dealing with that. Two strategies we're using, kind of where Aura was going here, on the query side or the view side or the bucket side, I guess you would call it, Michael. We have this pattern. We just call it named queries, but it says, put your SPARQLE query in the triple store and give it a name and give it parameters. And so anybody can find it. They query for the names of queries, and it will tell you what parameters you need, and you issue the query, and you get your results. Very much like what you say. What we like about that, the first thing we like about that, up to that point, thank you. Up to that point, people were sticking Sparkle in their code. And of course, that gives you the exact same problem as if you stick SQL in your code. Somebody changes the model and you have no idea what code has to change. And the nice thing about putting it in the triple store at ingest, you can just scan the text of the code and say, oh, it refers to people and employees and students, attach them to those concepts. So if somebody touches those concepts, you know which queries are broken, right? So that's, and on the other side, so that's more the reading side. The writing side, I think the best we have for developers now is Shackle. They, for the same reason they sort of like JSON, they sort of like Shackle. It puts just enough structure to their world that they can deal with it.
I totally agree with you. Yeah. I mean, so one aspect of this is that the pattern that I was proposing was a generic one. It could be applied to GraphQL or any other APIs. But the point is that the API is going to basically know about this control plane, is going to know about where the hints are. And if you want to embed the hints as a Sparkle query itself, that's fine. If you want to embed them as attributes of or parameterizations, or however you model these hints, so that the REST API can build queries, and the people on the front can then simply parameterize those APIs, you're good to go. The simplest example I can give is this. 80% of what developers do on the front end is to generate lists of things. And what are those lists? They're lists of business objects generally. List of books, list of movies, list of people in the organization, right? So all of these business objects, if they have a corresponding Shackle shape, then creating the hints around that shape is trivial. You can either query the Shackle shape itself, or you can explicitly put them somewhere else, where they're easily definable. And the idea here is, in terms of a URL, you might go, something like, my website rest / products / 1, 2, 3, 4, right? And so 1, 2, 3, 4 it would be the SKU of the product. But then the next one would be, you could then constrain it by a facet, for example. So the pattern on the URL that developers are going to use and test, should simply match the kinds of business objects you're going to have in your system. Now, they won't know how you model them, and actually they don't care, and they shouldn't care. What they have are business requirements on their end in terms of creating an application. So they should be able to tell you, these are the things I need. And at that point, you can determine either to do what you say, prepackage the Sparkle as an entity in the graph itself, or in the way Oracle does it is you create a PL SQL statement, which is part of ORDS, which is Oracle REST Data Services, and then that object spits out the REST data endpoint for you. It kind of doesn't matter, right? I mean, if you do it Oracle's way, you're going to do it somewhat similar to what you're saying, except that it won't be in the graph, it'll be in the ORDS piece. If you build your own Java or Julia or Rust or whatever front end, right? You're going to have to figure out where to put these things.
Right.
So that
let me react a little bit more to that there, because you bring up something interesting. 80% of what they do is trivial, right? These lists of whatever they're finding. Frankly, we want to get to a place where you shouldn't have to have an application programmer do that. We should take that off the table for, we're working on model-driven development. Anything that simple, I don't want the application developer involved.
Yep.
So
no, you're absolutely right.
Now we get to the other problem. So now we got the case, okay, there is some bespoke logic here. So they issue their query and they get back a let's say a JSON payload, and it refers to certain things. How do you stop them from coding to that? Because that's what they think they have to do. In other words, what's the strategy for not binding their code to the application? I mean, to the schema.
The great thing about Sparkle is that nobody on the developer side knows it, so they're never going to write any Sparkle, which is awesome. Whereas if it was SQL, they go, "Oh, I know SQL,"
Yeah.
And of course they make a mess of it. So
Yeah.
you know, the bottom line is it's payload first, and they have to document the payloads that they need. You can then either, if you're building from scratch, you can either build a model to support that, or you can enrich your existing model so that it supports it. Either way, right? It doesn't matter.
Mm-hmm.
And if they need a new custom query, well, they need it. They're basically, it's a new business requirement, and it'll have a new, a Scrum project, and so you'll have to come up with maybe more hints in your database or whatever, right? I mean, you know, if someone comes in and says, "Oh, now we need custom pricing," well, you're not going to put that into your semantic graph, right? You're going to say, "Oh, where are we going to get custom pricing?" Well, it's over here, and you know, this system over there. Okay, how do we merge that? Well, that's a back-end control plane issue, not a front-end issue. And so what happens is I mean, this is the dirty secret, right? We all talk about MVC, right? Model View Control. I have yet to see a single project that does it. Right? Every view is doing model-y stuff and control-y stuff. Every controller's got part of the model in it. I mean, you know, and then they go, why is it so expensive to make a change anywhere? It's because the system's fragile.
Yeah.
Right. Yep. So the point is this is why I really like Sparkle, right? Because you know it's so weird that we're kind of forced to make the object inside friendly, and to your point, shackles is our obvious answer here, and you know, Neo4j has shown us for sure people like things that look like objects. You know, it's just property graphs are, you know, that's what they look at them and go, oh, that's just a person with a bunch of attributes hanging off of it. I can model that in my world, and I've already got my object in my mind already. So they don't want to be searching. Yeah. So
Mark's got his hand up. Let's.
It'd be nice if I look at the screen every once in a while.
If you open up the little thing called participants, they'll bump, you know, they bump to the top, and you can see in the order who's got their hand up. So Mark, it's you.
I just wanted to come back to something that Aura said, actually, which was the object semantic mapping thing. So it's something that's been very close to my heart for the last year or so. Sorry, I keep relating everything to digital twins because that's what we deal with. But if you can think of domain-driven design's concept of an entity, and something in the ubiquitous language, you can say, okay, if I've got a digital twin of a train, for example, you can have a bunch of stuff in the database about the train. You pull that train out, you populate an in-memory object with that stuff, maybe some of the behaviors and things like that as well. You make changes to that object in your code, and then you persist it onto it as a digital twin in the network. And that's the way we're thinking of doing these things. So you actually use a digital twin as the bucket. That's why I sort of latched onto this bucket idea. Is a something where you can put some of your data, and it can be a bit of a mash for what Michael was saying of different sources, but you present it as a programmatic object. You do things to it, and then you might say share or something, and it shoves it back into the database, shares it with the rest of the network so that somebody else knows that it's changed. And then you end up with these digital twin ecosystems based around semantics and object modeling and code kind of all working together. I think of it like a huge real-time operating system running in the cloud is the way I think about it.
But how do you, in that scenario, how do you prevent what Michael was talking about? So somebody wants the digital twin of a locomotive, it comes, and it doesn't take them very long to figure out that there's an engine, or maybe there's a diesel engine, or and they want to, so they're going to start coding to engine and diesel engine, aren't they? Is that okay in your world, or is that something? Are we getting too bound to the domain schema then?
Well, that's that's such a germane thing to our very first ever customer with IOTIX was exactly about diesel power packs in trains. I don't think we've solved it. I can't put my hand on my heart and say we've definitely solved it. But the joy of the link data for us is that you can say, here's a digital twin of a train, and it has a property that says has engine or something, and then that points to another digital twin of the engine. So you go and fetch that, and you go, well, tell me about yourself.
Okay.
That's the model we use it.
Yeah. And so your meta model is what is a digital twin?
Yeah.
Not what is a locomotive. Yeah.
Yeah, exactly. So it's a digital twin is, has RDF type IOTIC digital twin, RDF type train.
Yeah, and then has direct part and blah blah blah. So there's a handful of predicates you need to know to make the thing hang together, right?
Yeah, and that's the kind of approach we take. Yeah. And then you can have semantic links between things, even between things that you own and somebody else owns, which would be nice. Yeah. And then you can share data through streaming through to other things. Now, my dream is to have it all expressed in RDF. And only the deltas, like when a temperature changes in a sensor.
Yep.
Why do I share that as a JSON in a stream?
Yeah.
Why don't I share that as an RDF diff? And everybody else goes, well, I've got the diff now. The temperature is 20 rather than 19. Well, great. I know the current state of that object. That's my dream.
Let me tell you about an experiment one of our guys did, which I asked him to do it, so I love it. So RDF Fox now will run a triple store in a Raspberry Pi.
Yeah.
Which is kind of cool for starters. And we had that exact scenario. We said, God, these heat exchangers and stuff, they're throwing out the temperature every 10th of a second, and somebody's putting them all in a historian in some goofy format. And just in case somebody wants to, no, come on, think about it. Yeah. What if you had Raspberry Pis there near your heat exchanger, turned that information into triples immediately, but then only forwarded it back to the mothership if there's a change in more than 1 degree in 2 minutes? Right?
Yeah. I'm sorry, I'm pointing at you.
And then,
absolutely.
But it's still sitting there in the Raspberry Pi. If somebody wants to do a federated query and come right back down, why did it change? But otherwise, in a month or so, just forget it. You're not going to care after a month why the temperature changed in the heat exchanger, because they change anyway.
Well, yeah, and that's the point. People store petabytes of data just in case something happens, and what the hell is just.
Yeah.
And the problem is that's the if you like the fallacy of big data for me. It's like you've got a big database, throw everything in there, it'll be fine. And then what you've done is throw all of the responsibility onto the consumers of that data to make some sense of it, and also to find all the needles in the haystack that you've carefully built for them as well.
Right.
Well, there's nothing saying we can't aggregate some of that. For example, like with temperature. You can average the day's temperature and just store the average for that day. I mean, instead of every microsecond, we'll keep it. We'll keep that for a few days or weeks or whatever. But in terms of what you a year from now, what are you really interested in? Well, more than likely you're looking at the average temperature, but whatever.
Yeah, or the big changes. But Aura's got his hand up.
Yeah.
So about 10 years ago, I ported all the RDF tools that I'd written for my PhD onto a Raspberry Pi. That included a triple store, a reasoner, query engine, and this kind of a browser that lets you explore data. And I mentioned this to a colleague of mine that, hey, it runs on a Raspberry Pi. And he says, well, of course it does, because the Raspberry Pi is way more powerful of a computer than the one you used when you actually did your.
True.
So there.
So is that available? Aura, is that tool stack available anywhere? Do you have a GitHub somewhere?
It is available in the sense that it's under BSD license. I just have to put it somewhere.
Okay.
It's basically a triple store. I was at Nokia Research, and basically developed a triple store that could run on very small devices. So it's written
Very
in C++.
cool.
Wow,
It's-
that's cool. Yeah.
The back end
Yeah.
is basically SQLite.
Yeah.
And then the query engine and the reasoner are written in Python that lives on top of the C++ implementation. It
Cool.
runs in a single process.
Does it have a name?
Piglet.
Piglet.
Piglet?
I love it.
Is it PY? PYG?
No, because such a thing already existed at the time.
Oh, okay.
So it's really just like a miln.
Yeah, I'm just
okay.
thinking, yeah,
Yeah,
is there a companion project called Eeyore?
Yeah.
Which does
My-
sentiment analysis.
My original, the original version of that was written in Common Lisp, and it was called Wilbur.
Ah, okay.
Which is another big, right?
Yep.
So Dave, one of my favorite of the talks was the one given by Siemens, where they were using CPQ to both read from the graph database, but then they would write back the configurations. And of course, the configurations were open-ended because, you know, each customer might have, you know, 2 widgets and 3 gadgets and red and black and whatever. And I thought that was just fascinating that you know, that they were taking a you know, very big enterprisey configurator and not only populating its rules and whatever through the graph, but also writing everything back into. And that reminded me a bit of what you were talking about with your digital twin.
Yeah, that roll-up thing, we did do that with the diesel engines. We rolled up the total operating hours for that day and stored that in the twin, so that you could then say, show me twins that have got more than 300 operating hours, and then you could send them for maintenance, you know, whatever, that kind of thing.
Yeah.
Yeah, so I mean, you know, the summary was give them things that they're familiar with. You know, give them things that look like buckets. The buckets represent handles. The handles can then be passed as an argument into the system to return a payload. The payload comes from a controller. The controller is able to merge data from multiple sources. And ultimately, and then you want those things to look like familiar business objects. So shackle is a key component to all this. And if you do that, I think you will find that front-end developers will absolutely be happy to work with these projects because they won't have to learn anything new. This just looks like a normal project to them.
Yep.
And you prevent them from screwing it up.
Yeah. I mean, absolutely. We had one of our clients, and this is kind of an extreme case. They did get a little bit pregnant with Sparkle, but they still wanted to do the things the way they always did them. So they would write these horrible Sparkle queries and try and load a gigantic. It wasn't a configuration, but it was a bunch of metadata. So they were doing this metadata project. They would load this giant thing into memory, and then they're pawing through it in the JSON file and all this. And of course, the performance was terrible. And this triple store doesn't work, and blah blah blah. All this. One of our guys said, no, don't do it that way. Just every time you need something, this takes 100 milliseconds. Why are you loading this whole thing that takes 2 or 3 minutes and then complaining about it? So yeah, I mean, you're absolutely right.
Well, front-end developers should not write SQL or Sparkle.
I know they shouldn't.
You know,
I know they shouldn't.
Yeah, and you know, the reality is, if you go with a payload first thing, then they have to document what it is they are need to satisfy their business requirements. And any project that doesn't have documentation is one that's going to fail. I mean, you know, whether it fails in the 80% of projects fail, or whether it's going to fail in the, you know, the Scrum is going to fail, I don't know. But it's the hacky nature of our industry is just legion, and it's really upsetting. And it doesn't take much discipline to get a beautiful result, but it does take some discipline.
Yep. Amen. What do you think? Anybody else have a further comment on this? I mean, it is a topical question for sure, because we're seeing it all the time. Chris.
So just I'm trying to replay what I've heard. It sounds like there's a fundamental problem of trying to match the business model that the front-end developer has in his or her head with the storage model in which the data is stored in the back end. And maybe the sort of solution that it seems to be coming out of this is, rather than the front end doing it, the back end to somehow find a way of providing views of the data that give the front end developer the business view that they want of the data. Is that the kind of thing we're talking about?
Yeah, and perhaps you're hinting at this. I believe the people who should be writing these Sparkle wrapped in PL SQL and converted into REST services should be the modelers, not the front end people.
Right.
Right.
Yeah, totally agree with that.
Yep.
You know, here's another tangent we've gone off on, and obviously I almost always start my thing as a purist. I would love to there be almost no code connection to the domain model. And there's certain things, you know, you just say, look, all these things are buckets, and here's how and it's a bucket of buckets, and here's how you display that in the table, and you can display any list of lists, you know. That one, you don't have to have any domain knowledge to do that. But sooner or later, you get a handful of things in the domain model. You say, you know, really, I do want them to know how to, for instance, display a georegion. Because until they know that this thing is a georegion and here's its shape file, not its shackle file, but its actual, you know, geometric shape, I need to know that and be able to, you know, code that against a geospatial thing, you know. So I'm starting to guess now that there are probably dozens of things that I would allow a programmer to program to, you know, time, you know, geospace, handful of things like that. But I don't want them to program to everything.
Well, as an example, if you do go the way I was talking about it, I generally Sparkle and semantic developers are not experts with SQL, for example. So, you know, you're going to want, if you want to do a merge from data that's over there, and you want to merge it to a table that's coming back from the your Sparkle, and do a join on it, basically. You're going to want a DBA who really knows, not kind of knows, but really knows their SQL, right? And so therein lies the problem. It's like the developer kind of knows SQL, you know, the Sparkle guy kind of knows SQL, and you know, it's like you end up going, well, we can't, you know, we got to get this thing out the door, so we're just gonna, you know, we'll hack something together and call it a day, and that's where things go south. I mean, yep. they just, I don't know. You know, the MVC is a great model, but everybody breaks it.
Yep.
Well,
Chris
it's not
is
a
back
great
on,
model.
but I also thought Mark wanted to say something, but he didn't put his hand up, so Chris gets the microphone.
Oh, thank you. Okay, so I just wanted to follow on that previous thought. So is what we should be thinking about giving the modelers the tools they need to develop business models of the data quickly and efficiently and effectively?
Well, if there's no front end work to be done, I wouldn't bother. You know, keep going your happy way with it, and keep your semantic data. It's semantic, and be happy. It's when somebody wants to present it is when your requirements get onto the table, and you shouldn't be making those decisions, right? The marketing people or the UI people, I mean, the people who are really expert at these things should say, this is how this application should work. And whether it's a geospatial or, you know, a 3D model or, you know, a train exploding and coming together, I mean, those are all completely different things that you shouldn't be hacking your model in hopes that you're going to hit the nail on the head. You know, they should say, for me to do my job, I need this to, I need this to work with.
Right.
And if they don't do that, then what they're going to say is, well, just give us a SQL interface and we'll figure it out. And that's exactly how most projects work.
Yeah. Yeah.
And it's horrible. It's horrible. I mean, the crap people make, and and then they leave and they roll off, and no one knows how this thing works. It's really bad. I mean, it's not just slightly bad. It's really bad.
Yep. And Mark's got his hand up now.
I put it up properly. There we go. No, I was just thinking, it feels to me like some kind of write-through cache stuck in the middle of something. So you go, here's the application grabbing data out of the cache. There's stuff underneath the cache, filling the cache up with stuff that the application needs. And then if the application makes a change to the cache, that's propagated down to the underlying systems in whatever way they choose to store the data. Is that the sort of thing you're thinking of, Michael? Is that what you would call your data controller thing you talked about earlier?
Well, right. I mean, the front end people shouldn't be dealing with cache except for at the page level. So, and in many cases, Akamai or something like that can satisfy. In terms of control logic, yeah, I mean, you hope that the databases themselves can cache certain kinds of queries, but not all queries are really cacheable, depending upon where the indices exist or don't.
Yeah,
so,
sure.
you do need to get a DBA in there at some point if this thing starts to become a highly scalable enterprise application, because, the reality is if you try to do join, a million record join against a million record thing, it's not going to fly, right? And there, but it worked in the POC. That's exactly what happens, right?
We used to have this guy who worked for us who had come from the resource-oriented computing world, where they'd spent a huge amount of money doing exactly what Mark just suggested, except at every juncture, every call to another thing was cacheable, and it had a URI. And in fact, he introduced us to this idea. One of the problems I don't like about most RESTful interfaces is they have this very hierarchical, customer orders, parts, and you can't do anything in a different order. But there is a syntax that I'd never seen before in URLs that, semicolons, and you can put them in any order, and his little caching thing took advantage of that. It was really kind of fantastic. I think it was just too great of a leap for people. It performed like crazy. It was really performant, because it's surprising how often you're seeking the same information. You can have lots and lots of little micro caches all over the place.
Yeah. Well, if done properly, I mean, there's certain tools that will do caching for you, and in the end, it just looks like a table. Oracle has a product called Coherence, and we actually created a model where real-time inventory was being locally cached around the country in different regions, and this was for a commerce website. But from the front end guys didn't know. They just said, "Oh, there's a table and it's called inventory," and we just query it, and we don't know anything about it. So my point is, I don't think you should be. The controller per se should have that responsibility. Rather, I think the architecture should support the caches in a kind of hidden way. And you should use a tool like Coherence, or one of the more advanced ones that are, whether you're caching result sets or tables or whatever, it doesn't really matter. It should just look like the familiar thing that I'm looking for. Because if you ask the developers to get involved in cache, again, they're going to make a mess of it.
Yep.
So I'd see that as more of an architectural problem.
Yep, absolutely. So last call. Anybody have one more comment or question?
No,
well,
apart from this, it's been great. Really enjoyed today.
Yeah, it's a lot of fun. Michael, especially thank you for doing that on the fly. And
I'm sorry about my hand puppet here. It didn't work.
Excellent. Well, thanks. It was a lot of fun. Take care, everyone.
See you next
time.
Thanks.
Bye.
Bye.